This topic is about the bifurcation in symmetric system with hysteresis on abstract Hilbert space. First of all, the main question arises when a bifurcation will occur. What is the number of bifurcated branches? What is the stability of the periodic solution, or what is the global behavior of branches? First of all, let me attention what is a Hopf bifurcation. For a given continuous parameterized dynamical system, a Hopf bifurcation is a phenomenon of the occurrence of periodic solution when the parameter crosses some critical values and the trivial solution changes its stability. If we give attention on the slide, I mentioned here a dynamical system with continuous right hand side if and my alpha 0 is my equilibrium point and the linearization A of alpha exists for all alpha. In this case, the Hopf bifurcation takes place when my equilibrium alpha 0 changes its stability. So it means that if we focus on the picture, it means that when a pair of complex conjugate eigenvalues of the linear adjacent crosses the imaginary axis, the Hopf bifurcation will take place. Next, we come to the what is a symmetrisis. Symmetrisis of the system F means if my gamma is a given compact Lie group and V, that is Rn, the orthogonal gamma representation, then F is symmetric with respect to gamma, or F is said to be gamma equivariant if F of alpha gamma y equals to gamma F of alpha y holds. Now the question is, what is the impact of this symmetrisis on my actual dynamics? It means that, as an example, if I consider my F is symmetric with respect to Z2 group, then my actual dynamics will symmetric with respect to the origin. Now, if I come to the context relevant to the Hopf bifurcation, then if F is a gamma equivariant, what are the spatio-temporal symmetrices to the periodic solution of the Hopf bifurcations? So it means that if y of t is a periodic solution, then the spatio-temporal symmetrices are the subgroup of gamma times S1, which consists of element of the type gamma ei tau, such that gamma y of t plus tau is equals to y of t for all t holds. This spatio-temporal symmetrices is known as the twisted subgroup. There are two choices of methodology. One is the equivariant singularity theory. Second is the equivariant degree theory. Among these two, equivariant degree theory is better to choose because I am interested in a system with degeneracies. That means it is a lack of smoothness, which has a lack of transversality, and also a multiple purely imaginary eigenvalues may occur. That cannot be discussed by the singularity theory, but it can be discussed by the equivariant degree approach. Here I mentioned a tentative model that I am going to work on, but this model is defined on a finite dimensional space, but I am interested on an infinite dimensional, that is an abstract Hopf bifurcation, abstract Hilbert space. So here I mentioned a partial differential equation that is a parabolic equation. Here alpha is my real parameter, x and theta are the input and output of an hysteresis operator that I will discuss. Means what is my hysteresis operator and why I need this operator in my system. Actually, this system is just a parabolic equation, but we introduce another operator that is the hysteresis operator. So what is the hysteresis operator? I'm interested on a system with a non-smoothness, and this non-smoothness comes from this hysteresis operator. And Ps4 model is the simplest hysteresis operator, and that I have already studied about. First of all, the non-ideal relay is the elementary building blocks for the Ps4 model, which is characterized by two threshold values, that is alpha and beta, where alpha is always less than beta. And for input x of t, the relay, the non-ideal relay, the output is eta of t, which is also known as the state of the relay, is defined by this notation, and it depends on the initial time and the initial state that is also defined here. And the state for at a moment time t is also defined by this equation. In a brief, this state always switches between two values, 0 and 1. It works like a transducer. How does it work? If we give attention on the picture, if my input value means it flow means goes along the horizontal axis, If by x the input values moves onto beta, it will be 0. But once it reaches to beta, it will take the value 1 and switch to the value 1. And until my x comes back again to alpha, it will remain 1. And once it reaches to the value alpha, it will switch to 0. And again, same thing, until it reaches to beta, it will remain 0. That is, it is just a switching system, means it will switch between the value 0 or 1. Now, I just want to mention what is the Ps4 operator. The Ps4 operator is just is formed if I connect such the non-ideal relay that I discussed before, building block. If I connect such non-ideal relay parallelly with a corresponding density function mu alpha beta, then a Ps4 operator is formed, where each of the relays are independent of each other and have the same input x of t, and they both all together contribute for the output theta of t, that is the Ps4 operator output, and it is defined by this equation. That is actually the area of this gray area with respect to the density function. Now, what is this S of t? That is the domain of this integration. It is actually the set of all order pair alpha beta such that the corresponding relay R alpha beta is switched on, but the other relays are switched off. This S of t and the staircase line and the corresponding characteristic equation or the function together known as the Ps4 state. Now, just let me give attention how this staircase lines varies according to my input value. If I give attention on the first picture, my input values is denoting by the horizontal line. Now, and it also controls the point on the diagonal. If my input values moves from the value u to v, then the point will drag this horizontal line upwards and the area will decrease by this dark gray trapezium. And if I now focus on the second picture, if I am now in my current position here and my x value, the input value, is moving from u to v, then the point on the diagonal will drag the vertical line from the right to left, and the area set by the triangle will decrease. So if my input is changes, then the area of the staircase means my staircase will change. That means my Ps4 state is going to be changed. So this is the overlook how the hysteresis operator is used in my model. And here are the keywords that you can search on. That is the symmetric Hopf bifurcation, equivariant system, what is the differential operator equation, Ps4 hysteresis operator, and the equivariant degree theory. This is the end of my presentation, and thank you. Let me know if you have any questions.
Thank you.